Okay, the problem is about there is a bar supporting a particular weight as shown here, and there are two springs K1 and K2 which support the verticality of this bar, and one is to find out whether what kind of stability occurs for the vertical position of this particular mass. As you can see here, when it is in the vertical position, and let's say K1 and K2 are in their unstretched condition, there is no force in the horizontal direction. And therefore there is equilibrium, right? So in order to find out the stability, what we need to do is we need to write the potential energy of this particular system. Okay, there are three components contributing to the energy. One is the mass, the other is K1, another is K2. Okay, K1 and K2 are because of the spring compression or extension. M is due to the potential energy, the potential change. So let's take the datum to be this. Okay, now this is very simple. The total energy can be now written as, mind you, there are other positions possible. For example, the mass could go into something like this, right? So let's say this is some theta, and if we write down the relationship for this, please remember we are only looking at verticality, and therefore this theta, for all practical purposes, is a position that we can assume. Okay, if we do that, what we'll get is, I'm sorry, I have to draw it something lower here. So there is a particular reduction that we see in this particular thing, right? And let's say we call this as y of m. Then y of m is the total length L of this rod times, this is theta, and therefore this is L cos theta. The other two contributions are K1 times how much ever it has deflected. So it would have gotten deflected like this. This should have gotten compressed like this. So this is extended, this is compressed. But however, spring energy is a square term of the deflection. This is equal to nothing but this length, which is 2/3. I'm sorry, this is for K2. This is 2/3 length K2 times 2/3 of L times, this is the distance we are looking for, which is sine theta square. Similarly, K2 is L by 3 sine theta square. So we have found out the energy. Now we have to take du by d theta, because theta is the one that refers to the position, is equal to, we have to differentiate this. Then we'll also find out d square du by d theta square and get an expression for that. Okay, and we will find out this particular value at theta equal to 0. If this is less than 0, then it is unstable. If it is greater than 0, it is stable. That's all. Okay. By the way, this is problem number 3 of tutorial 5. Thank you.